So let's get started with today's content. When we think about the section circle geometry, give me a sense of your feeling towards this topic in the chat. So feelings about circle geometry: happy, sad, somewhere in between. I just want to do a quick little vibe check in the room. Okay. All right. So there's a mixture. There's a mixture in between. Okay. So when I think of circles, there's a couple of different sections, but basically there's three main groups of facts that you need to know about. And so I always think about the first group being circles in the center. So let me see if I can do this. Circles and the center. So there's a whole bunch of facts that you need to know about circles in the center of the circle. Then the second group is circles and cyclic quads. And then the third group of facts that we need to know about to master circle geometry is circles and tangents. And so within each of these groups, there are specific theorems and facts that you need to know. But at a broad level, that's always how I think about it in my head. So if does everybody, let's just do a quick check. Does everybody know, I mean, what a cyclic quad is? Or let me just quickly make sure. So if we think about a circle and the center, I think that's pretty obvious, right? And so there's some theorems. Often there's things like the shape of the arrowhead that come into it, and some other theorems that are similar to that. Now, a cyclic quad is just a quadrilateral where the vertices are on the circumference of a circle. So that would be a cyclic quad. And there's some facts and theorems we need to learn about cyclic quads. And we also talk about the exterior angle of a cyclic quad. So it turns out the exterior angle of a cyclic quad is equal to the interior opposite. And then the last group deals with circles and tangents. And a tangent is just a line that touches a circle in one place. And then the theorems also have to do with like the point of tangency. And then normally there's something called a chord. And then this chord makes an angle, or the fancy word is subtends an angle at the circumference in the circle. Okay, so that was just my little quick look back on memory lane. Just give me a thumbs up if you are with me in general about those three groups and how circle geometry is really about those three groups of facts, and then obviously visually seeing those facts in drawings. Okay. Yeah, fantastic. Okay. So let us now, oh, wait, before I get going, we're going to get going right now, but I just want to give a shout out to last week, our quiz. We've started a new thing called the quiz leaderboard. And so a shout out to all of you who did the quizzes, but especially to Bokan, to Darren, Lesejo, Impo, Ianda, Anisipo, and Mokolashi, who got above 80% for your quizzes. Yeah, just want to give you a shout out because I know it takes a lot of hard work to do the quizzes, and I recommend them for everyone. And so we want to start acknowledging kind of the quizzes. Okay. So first little speed round. I want to know, answer this question for me. X is equal to what, and what is the reason? If you're stuck, you can raise your hand or ask a question, but if you know what's going on, write the answer in the chat. You've got 30 seconds. Okay, so X is going to be equal to 62 degrees. And the reason is angle at center equals twice angle at circumference. That's the reason. And the way we visualize this theorem is we think of the arc between B and C, or a chord between B and C, and the angle that's made at the center is that one. And then using that same arc, we make an angle at the circumference. And you can see the angle at the circumference is smaller, and it's smaller because it's actually half of this one. So X is 62. Okay. So again, stop me if there's a problem, but this is meant to be the speed round. So I want to get through this is like reviving your memory unless we need to stop further. Okay, question 2. I want you to find me X and Y, and you've got 60 seconds for this one. I thought I might catch a couple of you. So I'll highlight the so you guys are good. Wait. The sneaky one with this question is that we focus on that one and that one. And so that's how we get Y is 122. And that's also angle at center equals twice angle at circumference. Excuse my writing, guys. And then what is X going to be? So we know this is 122. I want to know, in fact, I want someone to come online, tell me not just the value of X, but I want to know the reason. What's the reason going to be? Who's going to give me the reason? Okay, David, let's unmute David.
Okay, sir, got a question.
Okay.
Inside this circle, is there not a cyclic quad in there?
It is a cyclic quad. You're quite right. So let me just use a different color. Let me use, get rid of that. So David, you're seeing this as a cyclic quad, which I agree with you.
Yes, sir.
So what does that mean? Can we find X with that information? David, are you still with us? Okay.
Yes, sir.
What do you think the relationship between X and 122 is going to be? So these are called opposite angles in a cyclic quad, and we say they're supplementary or they add up to 180. And so we go to find what X is, we go 180 minus 122, and we get X is 58. And the reason is opposite angles cyclic quad. So whenever you have a cyclic quad, the two angles opposite each other are going to add up to 180. I see Kaklecho put that in there. Now, that might have caught some of you. So I just want to get a quick check. Thumbs up if you're with me on that. Thumbs down if you're feeling a bit unsure with this one. Okay, so far, we've dealt with some theorems around the center of the circle, especially angle at center, twice angle at circumference. We've looked at the cyclic quads. Let's keep going. What is, in fact, we've done that one kind of already. Let's go on to this one. What is going to be X, Y, and Z? I want you guys to figure out what X, Y, and Z are. And then I'd love for someone to come on and explain how they did it if they feel comfortable doing so. Otherwise, put it in the chat. But if you, yeah, okay, David, how would you do Z?
Okay. Okay. So I first found X. X is going to be 100 because interior equals to the exterior.
Okay, so X is 100, and the official reason, I agree, it's exterior angle cyclic quad. Exterior angle. Okay, perfect. So you've got, this is 100. Thanks, David. Then I see Loretta has said Z is equal to 80. And I think I would just say sum of angles or angles on a straight line. So basically, that has to be 80. Now, the last one is Y. No one's given, has anyone given Y yet? Kakleko has, Dawn has. Does anybody have the reason? Or Atile, I see you got Y is 90. How do you know it's 90? Yeah, Younger, let's unmute you.
So it's 90 because opposite angles of a cyclic quad add up to 180.
So opposite, we just say opposite angles, cyclic quad. And so Y is indeed 90. So you can see how knowing these facts allows you to figure out a whole bunch of angles. I want to point out that whenever I write a statement, I write the reason that goes with it. And there's always going to be a mark for each of those things. Okay, so speed round is going nicely. Again, if I'm going too quickly, please do say something in the chat. But this is just kind of dusting away the cobwebs on this section, because I know it's been a while. So next one, little bit more detail. Let me talk you through the initial part of it. Whenever I see a question with more words, I take some time to just process it. So O is the center of the circle, which means the theorems that deal with the center of the circle might be in play. It says SP is 100 millimeters, and SP is this thing over here, which looks to me a lot like a diameter. It then says OT is perpendicular to QP. So that triggers a few memories for me, but anyway, so those guys are perpendicular. And then it says OT is equal to 40, and that's not actually written on the drawing. So I'm going to put 40 over here. And then it says calculate QP. So I want to give you 30 seconds to just think about this. And the goal is to find the length of QP. I would like ideas from the class around how we might approach this problem. I haven't written SP is 100, so I suppose I should say that SP is 100. Okay, so lots of people in the chat are saying Pythagoras is going to get involved in this. Any other additional ideas? So I agree with you. Okay, so Lesejo, let's go to you. What other ideas? Yeah.
So we already have OT. So you need to, because SP is a diameter. If you cut it in half, it's a radius, and OP is then half of that. So OP is SP divided by 2. So that should be 50. And you use the theorem of Pythagoras to figure out what TP is, and then you multiply that by 2 to get QP.
I'm totally with you. So OP is 50, and the reason is because it's basically it's, I suppose the way I would write it is diameter equals 2 radiuses, essentially. So you know you could cut it in half. Now you're right. We've given a right angle here, and you're saying we can figure out what TP is using Pythagoras. And in fact, I can see it's a Pythagorean triple. It's like the 5, 4, 3. And so TP is 30 millimeters. And we're going to say Pythag. And then the final step is QP. What's QP going to be then? And what's the reason we're going to need to use? So Fagelo has said QP is 60. I agree with you. What is the reason? Okay, Fagelo, what's the reason we're going to use?
Hello, everyone.
Hey.
It's because we are given that OT is perpendicular to, so can you please go up a little bit? I can't see.
There we go.
Yeah, OT is perpendicular to QP, which then concludes that wait, QT is equal to TP, which means that Q and P are 60.
Perfect. Okay, so there's a couple of ways you can write it. The one that I would just say is, it reads like English, you line from center perpendicular to chord. So basically line from center perpendicular to chord. And therefore you know that QT is equal to TP, right? So that's why this is just going to be 2 times 30. And what's 2 times 30? It's going to be 60. So like, if you look at what you observe here, line from center perpendicular to chord, therefore you know that this is going to be equal. And so that would be 60. Awesome. Let's just give me a thumbs up if pacing is okay and I can move on. All right. Let's do this one. So you need to find the length of OD. Ooh. Which is this length here. Take a minute, write down your argument for how you would find OD, and then I'm going to give you the answer. But I just want to give you a chance to think through how you would solve this one. You're trying to find the pink bit. Okay, so Pythagoras is going to be involved again. And let's, some other comments. OD is 6, it sounds like, from the people of the room. So I was thinking, you know what AB is, so then you know that AD is going to be equal to 8 centimeters, because it's given that AD equals DB, or you can some equivalent of that. So you know this is 8. And then using the theorem of Pythagoras, you can do it the long way, or recognize that it is, but there's something, I think Rona might be saying this. How can you use Pythagoras if there's no right angle triangle? Rona, you want to come? Is that what you were going to ask about? Let me unmute Rona.
Yeah, I was going to say, I actually wanted to find out what the question was, but now that I know, first of all, the first thing that you can see is that AB,
yes.
I mean, AD and DB are equal to each other, which means that OD bisects AB. That means that there's a 90-degree angle on either side of, so that would make triangle AOD a right angle triangle.
Okay, so let's do this. So what the important bit of information that you have seen is that you need a 90-degree angle before you can use Pythagoras. So you're right, yes. ADO equals 90, and the reason is going to be line from center to midpoint of chord, or line from center to midpoint of chord. Sometimes people just call it the midpoint chord theorem, although I think generally speaking, the more common way is line from center to midpoint of chord, and you can literally see it. It reads like English. Like if you look at, it's a line from the center and it goes to the midpoint of a chord. And when you know that, it means that the angle that's being formed is going to be 90 degrees. Now you have your right angle triangle. You can find OD, and you can do it by saying 10 squared equals 8 squared plus x squared. But you'll recognize that this is going to be, this is the 3, 4, 5 that's doubled. So it's going to be 8, 6, 10. So this is going to be 6 by Pythag. This theorem is not as well known. It doesn't get the same sort of attention that like angle at the center equals 2 times the angle at the circumference. And so watch out, because it does sometimes come up. There's actually one other theorem I also want to mention now that we're going through, like, oh, some sirens going past outside. So when I think about theorems that are forgotten a little bit, that this is one of the forgotten theorems. The other one is there's a theorem that says equal chords equal angles. And I'm just going to show you what that looks like. So if you have 2 equal chords in a circle and they make an angle at the center, they should have this notation on, then this angle over here and this angle over here is going to be equal. And so that's another theorem that gets forgotten quite a lot. In fact, if they make an angle at the center or an angle at the circumference, as long as the chords they're based on are equal, those angles will be equal. Okay, so that's just another theorem that came to mind and I wanted to mention it. You can always, it'll hopefully come up in a later question. Okay, last or second last question before the break. I want you to try and find me X, Y, and Z. I'll give you 2 minutes to do that one. Figelo, yeah, it's related to that one. Equal chords subtend equal angles. It's related to that, yes. It's a corollary of that. Oh, wait, it's a corollary of the angle at center is twice angle at circumference, but yes, you're in the right ballpark. Oh, the power came back on. No ways. Oh. There we go. So X equals. So Darren's got an answer there for Y. Looking good, Darren. I think I agree with you. Shoshana, the same thing. So Y is 90. X is 120. And Z, okay, we'll have to work that out. And 90's reason is going to be angle in a semicircle. Angle in semicircle. Oh, what happened there? So those are my 2 reasons. Now, for Z, there's a couple of ways we can do that. Yeah. Agree, Level, giving great advice there in the chat. Don't forget to write your reasons because that's where the marks come from, or at least you get extra marks for that. Now, Z, I think, yeah, like Rona's saying that sum of angles in a triangle, and I think you're onto that. Or the other way we could do it is maybe we could say that if we know that this is 90, isn't there a theorem we learned once upon a time called the exterior angle of a triangle? Does anybody remember that theorem? So if I think about, there's my triangle, and then the exterior angle of a triangle is meant to be equal to the sum of the two interior opposites, which are these two. And we know this is 90. Or what you could do is you could work out what this one is, which I think it looks like it's 60. And then you work out what Z is after that. And so you'll get Z is 30 degrees. Okay. So I'm just going to write, it's quicker, exterior angle of the triangle. But you could have also done 2 steps where you get 60 and then you get the 30 over here. Okay, are there any questions or comments on that question? We're doing nicely. There's still plenty of cool stuff to do today. Dawn's asked, how did I get 90? So there is a theorem, Dawn, that says that if you take the diameter, so let's say you have a circle and you've got the center and you draw a diameter. If the diameter subtends an angle, that's the fancy word for forming an angle on something, and it's based on the diameter and it forms at the circumference, this is going to be 90 degrees always. So if the angle had been formed there, or if the angle had been formed here, that would also be 90. Or if the angle had been formed here, that would also be 90. We call that angle in a semicircle. Was there a hand that went up?
Yes, Rona.
Yes. Okay, Rona, let's go to you. What's the question?
I have a question. Earlier on, you mentioned that to get Z, you need to find the sum of Y and the exterior angle, but didn't you mean the difference?
You're quite right. Well, okay. So it depends on how we word it, but this one over here is equal to the sum of these two over here. So the green one is equal to that. But you're right. The difference would be like saying 120 minus 90, and then you get the 30. So it just depends on what direction you're going in. But you must know that the exterior one is the bigger one. Yeah. Alrighty. Ladies and gentlemen, it's time for a break. Your body will thank you. So what I want you to do is to turn your cameras on and join me in standing and stretching. And don't just like sit in your chair stretching. Give yourself the full experience. Give yourself the full stretching experience. Oh,
come on, guys, please join us in the stretch. Switch
turn on your cameras and just indulge yourself with some fantastic stretching.
Give your mind a break. You've been working so hard.
Yeah. And also we're humans. We need, our bodies need like blood flow and, you know, oxygen, and I hear water is a good thing every now and again. Oh. Okay. Why is my internet being weird again? Nebo, are you still with me here, or am I? Okay, we're there. So keep stretching. I'm just going to do a quick transition to my normal big monitor, and so just keep stretching it out. And
I think there's a lag on my side, Mr. Ace.
Okay. I'm just going to switch over to my monitor so that we can have a bigger screen to work with, and so I can also be able to draw a bit easier and make sure I'm plugging in the right stuff. What am I meant to be plugging this into? Okay, well, we'll figure that out in a moment.
Can you hear me now, Mr. Ace?
I can hear you, yeah.
Okay.
And I'll be with you shortly. And there's my other, oh, that was a pretty smooth transition. It used to be pretty hard. Okay, so brain break time. This is, okay, I'm being a bit nasty today, but anyway, let's indulge ourselves. When my father was 31, I was 8. Now he is twice as old as me. How old am I? Mm-hmm. You have to think about this a little bit. Okay, I know you're getting warmer. Chloe's, well, Chloe's, can you explain how you got it, Chloe?
Because if you minus 8 from 31 is 23. So if he's twice your age, he's double 23.
Yes. Oh, you got that quickly. So the way I was going to say it is, okay, back in when my father was 31, I was 8. So imagine when you're 8, basically you're X and your father is going to be X. Well, the difference between 31 and 8 is 23. So X plus 23. And then, I mean, essentially what you want to know is, I think I'm making it more complicated than it needs to be, but all I was going to do is say that when is X plus 23 equal to 2X? And then if you take away X from both sides, you get X is 23. And so double 23, the father would then be 46. Yeah, but I think, yeah, Chloe, you got that very quickly. Sure. Well done. Same Shoshana. Does everybody kind of understand? So if you're 8, basically it ends up being the difference between 31 minus 8. And then he's twice as old as me. So then if 23 doubled, the father would be 46. Give me a thumbs up if you're with me on this. Thumbs down if you just want to. Okay. So the other thing to think about is if your father was 23 years older than you at some other time in life, your father is still going to be 23 years older than you. So that's not going to change. But you're looking for the point when your father is double your age, and double your age at any point in time is going to be 2X if you are X to start with. And so that's kind of the way my brain thought about it. And then you just solve for X. And so you're 23 years old now. Okay. All right. Let us go back to this one over here. Now, I think you've got that one in the bag. So let's go to something a little bit different. We have been ignoring an important group of facts related to circles, and that is the tangents. So what we have here is we have a tangent. And I would like to know what X, Y, and Z is. If I've gone a little bit quickly, then please do ask a question, but I want to know what is X, Y, and Z, and what is the reason we use for knowing what X, Y, and Z is.
Mr. East, we have a hand from David.
Yes.
Sir,
yeah.
Could X be 45 degrees 10 chord theorem?
David, you have nailed it. Tan chord. And just to show you what David has seen, he's basically recognized the angle between the tangent and the chord is equal to the angle in the alternate segment, or the tan chord theorem. And we basically know that this angle here is equal to this angle here. Very well done. And then I suspect after recognizing that, you'll go, well, but then by the same reasoning, I'm sure these two are in relationship. So what is y going to be? So I'm seeing in the chat Younger, Fagelo, Darren, Shoshana. Yeah, so y is 60 degrees, and the same reason applies. It's just going to be the tan chord theorem. So this is 60, this is 45, and then what's z going to be? There's no center of the circle here, but there is still geometry. And I see in the chats, everyone is realizing that, well, there's two ways. You can either say that angles on a straight line add up to 180. So this one is 180. Or you can say that the triangles add up to 180. So sum of angles in a triangle. Either way, you're going to get this, which is 75. And I'm just going to put sum of angles in a triangle. So that is the tan chord theorem. That's not the only theorem involved with tangents. There's also something called the tan radius theorem, but there is no center point in this drawing. And so you couldn't use that one there. And also the other tangent theorem we know about is something called tangents from a common point. But again, because there's no tangent from a common point, that one looks a bit like this. Looks like, you know, giving the world a hug. But that isn't available in this one. So, yeah. Let's do 24. What is y? What is z? I'm remixing now. I'm throwing different combinations together. Okay. So another important theorem is sometimes called the butterfly theorem, and it relates to cyclic quads, and that is angles in the same segment. And so y is 68, angles in the same segment. And this one is, so if you think about the arc is here, and it's forming an angle in over here, and it's also forming an angle over here. And so that's why those two are going to be equal. What is z going to be? So kind of think of that one and its relationship to this one. What's this angle going to be? So we said this is 68. What relationship are they in? Z and 68. Is it going to be 68 again? No, it's not. Because that's the angle at the center, that's the angle at circumference. So this is going to be 68 times 2. Angle at center is, and so that should be 120, 136 degrees. Okay, so let's keep moving. I want to know what X, Y, and Z are in this drawing. So X, Y, and Z. And also I want you to give reasons as you go. Okay, so if I'm looking at the chat, most people in the chat anyway are saying y is 90, and I recognize y because this is a diameter. And so it's the angle in the semicircle. So angle in semicircle. So this is 90. And now, if we look at Z, it seems to indicate that, well, sum of angles in a triangle. So it just must be 180 minus 90 minus 30, which is 60. Sum of angles in triangle. Okay, but now the mystery guest, the one that is making life a bit difficult, is what is x? Who would like to explain to me their thinking on x? I see some answers coming in. I'm not sure yet if I agree or disagree, but I'd love someone to come have a bash and try and explain it. Rona, let's unmute you.
I was going to say that the theorem we're going to use to start first is when line from center meets tangent, then the angle is equals to 90.
Aha,
right?
so you're saying this
Yeah.
one here is 90.
Yes.
So we're going to say OTB. So OTB is equal to 90. And we often say line, say line 10. My brain has gone thing for a moment. Let me just quickly check what the official reason is. Here is the tangent perpendicular to radius. Yeah. Don't know why. Tangent, so tan radius basically.
Yeah.
So this so the tan radius theorem, this is going to be equal to 90. And if that's equal to 90, then x has to be equal to 180 minus 90 minus 36. Is that what you were thinking, Rona?
Yes.
And what was your answer?
54.
Okay. Yeah, looks great. Cool. So tan radius is another theorem that comes up quite a lot. And so that gives us a right angle. And you can imagine how that could work Pythagoras and all sorts of theorems like that into things like that. Okay. So we're going to do this last one, and then we're going to do one exam question for today before we finish off. So find me what Z, W, X, and Y are.
Mr. Ace?
Yeah.
I'm just asking if you can please explain the tan radius theorem again.
Okay, so the tan radius theorem is just the fact that whenever we have a tangent and a line from the center or the radius to the point of tangency, that will be an angle of 90 degrees. So whenever we see a line from the center, or a radius is another way of saying a line from the center, to the circumference, and it's the point of tangency, that relationship will be a 90 degree. And we call that theorem the tan radius. Now, I can spot the tan radius. I don't know if it's helpful, but you can see this is a radius and that's a tangent. So this would be 90, but it may not be helpful in this case. So, you know. All right. Might be helpful in this case though. Or is this a tangent? PR and PQ are tangents to the circle. So PR and PQ. Okay, so those are tangent, and they're from the common point, yeah? They're from P. So that's also helpful. There's a lot going on in this drawing. Trying to think which one I would start with. I see Chloe got W, and I agree with, I think what Chloe would have done, Chloe can jump on if she wants to, is you recognize the cyclic quad, and you realize that this angle here and this angle over here have to add up to 180. So if that's the case, W must be 180 minus 110 minus 48. And that would be opposite angles cyclic quad, which is, what do we get for that one? 22. Yeah. So this one is going to be 22. We still need quite a few more. So Dawn has said Y is 44. Dawn, could you give us a reason as to how you got 44? Maybe X is 68. Oh, okay, I think I know where that's coming from. Tangents from a common point. So we found W. We haven't found Y yet, though. So, but I might be looking at this. So I totally agree. If you've got Y, then you can use the tangents from a common point. I was thinking X is going to be, okay, let me point this out to everyone. This is a radius, this is a tangent. And so what do we know about the angle? We know this is 90. So because that's 90 by the tan radius theorem, we can just go that X is 90 minus 22. Tan radius. And so X would be 68 degrees. Give me a thumbs up if you understand that. Yeah. And then, using what Dawn was saying, is that if that's 68 and that's 6, well, basically, you know that this is going to be 68 because these two have to be equal from tangents from a common point. So what I'm going to say, there's a couple of ways you could do this, but I'm going to say PUR is 68 degrees, tangent from common point. And then I'm going to say Y is equal to 180 minus 68 minus 68, which gives me 44. And that is going to be sum of angles in a triangle. Sum of angles, triangle. So that would be 44. Is there anything that we haven't got yet? We haven't got Z, I do believe. Actually, I think this is going to be our last one for today. We'll start the whole exam. But we haven't got Z yet. Who would like to, can I zoom out like this? Is that okay, Nizole? How do we get the Z? which is here. Aha. Okay, so if we look here, it should be a tan chord theorem. Yeah, there's a lot going on here. Here's a tangent. Here's my chord. And so you could just go. And so then Z will be the same as X. So Z would be 68 degrees. And that's the tan chord theorem. And we've got that. Love it. All right. Are there any questions? It's still cut. Can you move more to the left? I can. Is that, or do you mean the opposite way? Okay. All right. So what we're going to do is in the next lesson, I'll just give you a little preview of what types of questions we're going to do look like. But I think today was great for just getting the circle geometry ideas coming back. And so, the part with the working out. Okay, let me move across like this. And then I'll just show you a preview of what the next lesson will look like. Just take a screenshot if you need to. Okay, so what do exam questions look like for circles? So if we think about this question over here, this is from an old exam, I can't remember which one it's from. It says in the diagram O, in the diagram O is the center of the circle, the diameter, okay, the diameter is LR, and it meets there. N is another point on the circumference, and chords LN and KN are drawn, and L1 is 58. Let me, if we look at this question, you can see how this type of question is related to the content and ideas that we've spoken about today. Okay, so in the next lesson, what we'll do is we'll roll through a bunch of old exam questions that use the ideas that we've done today. Okay,